multi-step formulas. So now the strategy is going to be the same with numbers, as we're first going to solve for a certain variable using the other variables kind of in the expression, and then we'll actually solve for them. And then let's go over a few things first. So this is really important, is does the following work? We have xy plus z over x. Does this become y plus z? Essentially, we're asking, does these x's just cancel out? And the answer is no. And why does it not work? Because, right, if we were to split up this problem like this, so xy plus then z over x, which is exactly what this is. If we were to, right, we can rewrite this again as xy plus z over x. So when we do this, only these x's cross out, so this just becomes a 1. But so then we have y plus z over x, because we don't have an x on top right here, right, with the z. So then therefore this doesn't work. So we have to be really careful that we don't make these kind of errors in our problems. So let's go over a few examples. Example 1. A platform diver in the circus just made a dive into the water below. The kinetic energy, so mid-dive, is 12,000 joules. If her mass is 54 kilograms, what is her velocity, v, at the moment in terms of the other variables first, and then the actual number? So we're going to use the kinetic energy formula below. So we have Ke equals 1/2 mv squared. So for this, so let's go ahead and start solving for, right, we're solving for velocity. So this is our velocity, v squared. Now, do we want it v squared or do you want it just to be v? Correct, we want it just to be v. We don't want v squared. V squared is velocity squared. We just want the velocity. So we're going to have to do an extra step there. So let's first solve for v squared. So let's get it all by itself. So let's go ahead and rewrite this. We have kinetic energy equals 1/2 mv squared. Now we have 1/2. So let's go ahead and get rid of that on the right hand side because we want v all by itself. So we're going to go ahead and multiply this on the right by 2. We can write 2 over 1 because we want to then get this to become just 1. Right? And then we can just go ahead and multiply, which we can put 2 over 1 or just 2. So now let's go ahead and rewrite this. We have 2 Ke equals mv squared. Now we need to get v squared by itself. So we have an m we need to get rid of. So we can go ahead and then just divide by m on both sides. This gets rid of it here. So now we just have 1 v squared. So we have, then on the left, we have 2 Ke over m, which is equal to v squared. Then how do we get to just v? Well, remember when we have a v squared, we take the square root of 1. So then we're left with just v, right? So if we take the square root of v squared, we're left with just v. So then on the left-hand side, we have the square root of 2 Ke over m. So we can't get rid of anything because there's not, right, the square root is really kind of asking like what, like so 64, right? Let's kind of go back over this. If we have 64, really this is just 8 squared. So then this just becomes 8 because we have 2 of these. So square root kind of looks like that. So this is just an example to kind of refresh on square roots. So now we have what v is equal to. So now we can go back to our problem and then start to solve for it. So let's go ahead and write it right here. So we have the square root of 2ke over m, which is equal to v. So let's go ahead and start solving. So we have 2, then let's look for ke, which is going to be 12,000. Then we put this over m, which is going to be her mass, which is 54. And this is equal to v. So now we need to go ahead and start to solve. So let's get our calculators out. So you have 2 times 12,000, which would be then 24,000. And this is over 54. We can just put that in square. Divided by 54, which is equal to 400. And then let's just round to the nearest hundredth. So we have 444.44. And this is the square root. So we're still in the square root. So we have to do one final step, which would be just to take the square root of it, which is this sign right here. So if we take the square root of 444.44 and continue on, this is 21.08. So we get our v, which is then v equals 21.08 meters per second, or we can show it as like this. So this would be our final solution. Now let's do another example. Example 2. A block weighing 10 kilograms, which is our mass, is at rest and slides down a frictionless ramp that is 30 degrees from the floor of the bottom. The block then slides an additional 5 meters along the floor, making the height y, which is y initial, of the slide to be 1.5 meters before coming to a stop. Determine the speed, which is our v, of the block at the bottom of the ramp if g is 9.8 meters per second squared. First, in terms of the other variables and then the actual number. So here we're solving. So in case you're not familiar, this is potential energy, which is equal to kinetic energy. So this is the equations for both of them. So if we were to write PE, which would be mg y I, or kinetic energy, which is 1/2 mv squared. So these are equal to one another. So what happens is the potential energy gets converted to kinetic energy. So what we're doing is just solving for what we know within potential energy to find then the velocity, which is going to be our v. So first we're going to solve for just our v. So it's kind of similar to what we did in the last step, except we have all these numbers first. So we have mgyi is equal to 1/2 mv squared. So our first step, well, let's just go ahead and get rid of this 1/2 on the right hand side. So we get rid of it by multiplying by 2/1, or just 2. This just becomes 1. And then on the left hand side we have 2 mgyi, which is equal to mv squared. Now in the next step, let's get v more by itself. So our next step could be just to go ahead and divide by this m on both sides. This gets rid of it here. This is just left with 1. Now in this step, we have an m here and an m here. We can actually get rid of both of these, and these just become 1, because m over m is just 1. So this only worked because in the beginning of this first video here, we showed it with an addition or subtraction. So this works because this is all multiplication, and then we're just dividing it by one of the variables. So then we can go ahead and just get rid of it. So now we have 2GYI is equal to V squared. Then we go ahead and solve for V squared by just solving for V, so we just take the square root on both sides. So then V then becomes the square root of 2GYI. And this is the answer to our first part that we need to solve for. Now let's go ahead and solve for this in terms of the numbers now. So now we have V, which is equal to the square root of 2GYI. So V is equal to, now the square root of 2, now G, well G is given to us 9.8, and then we need to find Y. I, which is given to us as well, which is 1.5. So now we can go ahead and now multiply all these numbers and take the square root of that number. So let's get our calculators out. So let's go 2 times 9.8 times 1.5, and we're going to get 29.4. Then we just go ahead and take the square root because we multiplied everything within. So take the square root and we get 5.42, and that would be our velocity. So our velocity, 5.42 meters per second. Or we can show it like that, and that would be our answer. So this is what it represents here in just terms of the variables, and then here with the actual number. Now let's do one more example. Example 3. Solve for 3, and then in parentheses, a plus 2b plus 5b is equal to negative 2a plus b for a. So for this problem, as you can see, we don't have any numbers. There's no story to go along with this. We're just solving for a. So we're going to just go ahead and treat this like it was like numbers and go ahead and start solving. So when we look at this, we see on the left-hand side, we see we have to distribute. That was one of the first things. So let's go ahead and deal with that. So we have 3 times a, which is just 3a, then 3 times 2b, and this is plus. So 3 plus 2b is then 6b. Then, I'm going to leave that in parentheses, plus 5b, which is equal to negative 2a plus b. So now we can go ahead and kind of look for like terms to see on either side if we can kind of make this a little bit easier. So we see here we have a 6b and a 5b, so we can actually add those together. Then on the right hand side we don't have any like terms, so we can't further simplify. So let's go ahead and rewrite this. We have 3a, we have nothing else on the left hand side, so it's just 3a. Then we have 6b plus 5b, so that would just be 11b, because 6 plus 5 is 11. Then this is equal to negative 2a plus b. Now we're solving for a. So like with numbers, when we're at this step, we start to put a on all by itself on one side. So let's go ahead and do that. So let's go ahead and move this negative 2a, because this is the lesser of the two values of 3a and negative 2a. So let's go ahead and add 2a to both sides, because we do the opposite. So this is negative 2a, so we just go ahead and add. This becomes 0. Then we're left with b. We have an equal sign. Let's bring down the 11b plus, now 3a plus 2a is just 5a. So now we have 5a plus 11b equals b. So we need to go ahead and continue to isolate a. So now we can just go ahead and subtract 11b on both sides. Notice that this is a b, so we can go ahead and just write the 11b below it. This just becomes 0, so now we have 5a, which is equal to, we don't need to bring down the 0, so we have b minus 11b. So 1 minus 11 is then negative 10b. Now we have 5a, which is equal to negative 10b. So now we need to solve for a. So we just go ahead and divide both sides by 5. So we're left with just our a. And now we have negative 10 over 5. So that would be negative 2b.